How do robots learn and adapt using algorithms? Imagine a robot that can improve its skills without someone telling it exactly what to do every time. It can figure out new ways to complete tasks on its own. That's what writing robot algorithms is all about. These algorithms help robots learn from their experiences and change their behavior based on what they learn. This process is at the heart of robotics engineering and development, especially when programming robots to act smartly and independently. Robots learn by using different types of algorithms that analyze data from their sensors. These sensors can be cameras, touch sensors, or distance sensors. The algorithms look for patterns in this data to make decisions. For example, a robot can learn to avoid obstacles by recognizing patterns in sensor readings. Over time, it gets better at navigating around objects without needing new instructions from a human. One common way robots learn is through machine learning algorithms. These allow robots to recognize patterns in large amounts of data. For example, a robot can be trained to identify objects by analyzing thousands of images. Deep learning is a special kind of machine learning that uses artificial neural networks. These networks are inspired by how the human brain works. They help robots understand complex data like images, sounds, or sensor signals. This makes robots better at tasks like recognizing faces or understanding speech. Reinforcement learning is another important method. It works like training a pet. The robot tries different actions and gets rewards for good results. If it moves in the right direction or picks up an object correctly, it gets a reward. Over time, it learns which actions lead to the best results. This type of learning is great for teaching robots to move, navigate, or manipulate objects in changing environments. Imitation learning is when robots watch humans or other robots perform tasks and then copy them. This way, they learn complex skills without being programmed step by step. It's like learning to ride a bike by watching someone else do it. Robots observe the actions, understand what to do, and then try to imitate those actions. Sensorimotor learning combines what robots see or feel with how they move. For example, a robot learns how to grasp a fragile glass by adjusting its grip based on sensor feedback. It uses machine learning to process the sensory data and change its motor commands in real time. This helps robots perform smooth and adaptable movements, like walking or picking up objects. Robots also use algorithms for motion planning and navigation. They calculate the best path to reach a goal and change their route if they detect obstacles. For instance, a robot working in a warehouse can learn to avoid boxes and find the quickest way to deliver items. It constantly updates its route based on sensor feedback, making its movements smarter and more efficient. Object recognition and manipulation are key skills robots develop through learning algorithms. They analyze features like shape, size, and texture to identify objects accurately. Once they recognize an object, they plan how to grasp and move it. If the object is fragile or heavy, the robot adjusts its grip accordingly. This ability allows robots to work safely and effectively with a variety of objects. In real-world use, these learning algorithms help autonomous vehicles navigate busy streets safely. Industrial robots improve their efficiency by learning to handle different parts and adapt to new production lines. Healthcare robots learn to assist patients better by understanding individual needs. Service robots get better at understanding speech and gestures, making interactions more natural. To sum up, robots learn and adapt using a mix of machine learning, deep learning, reinforcement learning, and imitation learning. These algorithms process sensory data and guide robotic actions. This way, robots can develop new skills, improve their performance, and operate on their own in complex and ever-changing environments.